Thank you, Dean Noria, and to all of the others who have welcomed me today. This is not an easy lineup to follow, I will say. I want to just start off by talking about aging, and I won't go too deeply into it because we have heard so many of the statistics all day long about what these demographics look like. I want to pick up where Dr. Hodes left off and really talk about Alzheimer's disease. That is the disease that our company focuses on. And it really is one of the largest disease concerns of our generation. Certainly, it's the greatest unmet health need. What we know is that 1 in 3 people will get Alzheimer's disease by the age of 80. That's bigger than breast cancer and prostate cancer combined. As global populations age, Alzheimer's rates increase. And we have 5.7 million people living with the disease in the US today. But we expect that number to reach as high as 14 million by the year 2050. You know, that's looking at just the US alone. When we think about what those numbers, those statistics look like at a global level, it really is astounding. Around the world, that number is estimated at around 50 million people today. And with rates doubling every 20 years, it's estimated to be 75 million in 2030 and 130 million by 2050. I'll just go back one slide, because I jumped ahead a little too closely. That will show you, what some of these numbers look like by region. These are staggering statistics. And they are statistics that will, in fact, nearly bankrupt many countries, including the United States. Current lifetime costs of treating Alzheimer's disease is around $341,000. And when we break down what those costs include, they're basic things like basic care necessities, food, medical supplies, many of which Medicare covers, but most of which they don't. And so you think about the type of financial burden that families are assuming in caring for somebody with Alzheimer's disease, and those are just the costs. That doesn't take into account the lost work hours that people have, having to leave their jobs in order to care for someone. Without some sort of greater solution, these are very concerning numbers. So a lot of money has been spent in search of a cure or a vaccine, and we've heard a bit about the amyloid hypothesis. I'm of the view that the amyloid hypothesis is largely a misguided one, even though we see the amyloid build up in brains through PET scans. The number of drugs that have had an amyloid target that have failed is nearly 100%. So while amyloid may be the best way of measuring certain aspects of the disease, it is not, looking at amyloid is not a definitive diagnosis. And what we have also learned about Alzheimer's is that in the past 40 years, AD pathology and etiology that has led to the recognition that it is more of a heterogeneous condition that is difficult to identify in the earliest of stages. So if you look at some of the numbers here in this chart, what you are seeing are 4 symptom-treating drugs and many, many disease-modifying trials that have failed. The list of experimental drug failures continues to grow. And we have seen, just about every major pharmaceutical company either shut down their program or, have to close it as a result of failure. Since 1998, there have been 100+ attempts at developing a disease-modifying drug for Alzheimer's, and 99.6% of them have failed. The good news about these failures, though, is that we have learned a lot about the disease, what has, through what hasn't worked, as much as we have been trying to figure out what will work. And what we know is that Alzheimer's pathology rarely occurs in isolation. In fact, 2 out of 3 cases have neuropathological processes that are present. We know that lifestyle and behavior play a massive role in health outcomes. And what is now growing is a very large body of evidence that shows that some form of multi-lifestyle intervention can be extremely effective. So as we at Neurotrack, the company that I helped to start and now run, continue to study this, together with a network of studies around the world all over Europe and Asia, there's no question that we need to keep challenging science in the area of multi-domain validated research and advocating for real science as we see it in other areas, but to keep that research very honest. We need to challenge, I think, this sort of pseudo-medicine that has the tendency to pop up in this area of preventing memory loss and stay focused on what we know really works. So I think that one thing that is very important to us is that as much as we have been solving for physical health, solving for that physical health has not included solving for declining memory. And what we now know is that helping people live longer and having their cognition keep up with the advances in physical longevity is a very important area that we need to continue to help solving for. Understanding how people get sick and die has been historically our data on aging, rather than the behaviors that people engage in, like diet or lifestyle. And traditionally, we've only thought about advancements in this area through drug development. We really have not considered any other options. And I think that we need to really think outside of the box, so to speak, push the boundaries in terms of exploring new layers into behavior and modification, and examine drug development and technology as well as prevention and treatment of disease through prevention. For all of the molecules and mechanisms of action that target drug research, that are part of drug research, we can also harness a very new and large set of technologies as part of our arsenal. At Neurotrack, we really view technology and science as 2 areas that need to work very closely together to give us more tools and, in fact, data to inform what has been, in many ways, a single approach to Alzheimer's disease in a much more comprehensive and unprecedented way, such that we can do a better job of fighting this battle. So despite the fact that there are many in kind of the aging demographic that struggle with technology, what we have seen is that technology use overall has been growing. And using technology to better manage care and improve health outcomes has been proven. And I think there is a real promise that we have not yet realized, but that as generations who are very adept at the use of technology continue to age, we'll be able to really take advantage and leverage of the role that technology can play. As aging populations fully integrate into that technology use, we have new ways of understanding more fully and getting greater access to the data around the science of aging. So if you take a look at something as simple as the Apple Watch, which in Silicon Valley many people wear, in other parts of the country not quite as many, but it really has transformed the way that people manage their personal health. And you see large sectors of the healthcare industry who are now partnering with Apple and with other smart watch and phone technology companies to help further grow adoption in the area of technology, wearables, and then being able to collect that data through those wearables. So we think about this use case as digital phenotyping. So using smartphones and the data that people sort of give away for free every day through social media, the rise in devices like the Alexa and the Google Home, where we've seen just astronomical sales and use in the home of those types of things, that we're able to collect massive amounts of data. And all of these points of data from individuals can be used in a variety of measurement. It's been used by us in very successful ways in assessing and treating and measuring cognition. It has also been used in different ways in terms of measuring and monitoring mental illness and mood and behavior types of issues. And what we focus on is really what we call the multimodal phenotyping for Alzheimer's disease, which can give us better ways to monitor adults as they age and understand in a more comprehensive way through the activities of people's daily living how the disease develops, how to engage target populations who are at risk earlier, and then ultimately through behavior change and habit formation, how to really impact the disease. I think phenotyping is particularly exciting for Alzheimer's because through it there's the potential to collect really massive amounts of data and assess that data from hundreds of thousands of people in the US and around the world to get a better set of longitudinal data on cognitive performance. Skip ahead once more. Actually, I apologize, go back once. So through access to different population groups, we can build data sets that can look at various types of aging individuals and their different trajectories. And this can dramatically change how we approach Alzheimer's altogether, pivoting from a position of defensiveness to one of offensive. And given that by the time an individual shows symptoms of Alzheimer's disease, they've actually had the disease for 20 to 25 years, collecting this kind of data will really give us tremendous insight into what we can be doing long term to prevent the disease. So Neurotrack is the company that I co-founded with a team of neuroscientists out of Emory University. We have a suite of cognitive assessment tools that use eye tracking to assess an individual's risk for Alzheimer's disease and then to monitor their potential progression over time. The beauty of being a technology that can be used on a phone or on a laptop or an iPad is that it gives us the reach and the ability to access patients all over the world. We now have 100,000 users from more than 165 countries. And you think about the type of data that a biomarker can generate. It's very limited in its scope, but when you bring in the digital component and the accessibility that we have through digital diagnostics, it really is game-changing in terms of the types of insights that we can get into diseases. We now have the largest data set of eye tracking data in the world, and we are using that data from our cognitive assessments to really look at a whole new set of features as it relates to the disease. By looking at not just outcome-based task data, but by the way it is delivered and collected through voice and haptic eye tracking, being able to evaluate an individual's state of emotion, we can explore and understand things going on deep inside the brain that have not traditionally been able to be explored or collected. This type of insight into areas such as pupil diameter, location setting, fixation, gives us a longitudinal look at cognitive performance and at vast scale. And ultimately, if we're successful at what we're doing with this kind this kind of data, I think we will have an unprecedented view into how people are aging across tens and hundreds of thousands of people over the years. We hope to harness the insights that our data scientists and our computer scientists have made possible to the insight and the trends to potentially help develop therapies to better target the disease and to effectively engage with users, most specifically around prevention. So what we're learning about Alzheimer's, and this was a key insight of the company about 2.5 years ago, is that, as discussed earlier, what we now know is that Alzheimer's, in somewhere between 1/3 of all cases and potentially as many as 50% of all cases, really acts more like a chronic disease and can be prevented through modifying certain lifestyle risk factors. You see here a product that we have developed. This is what we call our memory health program, and we pair this with our digital diagnostics, such that once we give an individual a diagnosis, we can, if we believe that they are at risk, immediately put them onto a program that takes the very best in science around diet and exercise, managing stress, your sleep, staying cognitively engaged, and in some ways, as importantly, or perhaps more importantly, around social engagement or to counter loneliness, which is as Sachin discussed earlier, is a very big risk factor for Alzheimer's disease. What we fundamentally believe is that, and this is a subject of great discussion here, is that people deserve to live long, meaningful lives, and that the battle for memory health needs to be fought in many different ways, in the lab, in tech startups in Silicon Valley, and that the only way that we can do that effectively is if we are able to collect data across the spectrum, both through molecular and biomarker means as well as digitally. And I think that if we do this and we do it well, it will lead to enormous insights into Alzheimer's disease, how we prevent it, and ultimately how we develop a cure. We know that with access to data comes a whole host of discussions around data and privacy, and it's clearly something that we take very, very seriously. We do so in all the right ways. But I think as well, encouraging trust across groups, whether it's customers or partners, is absolutely paramount. And we believe that the ecosystem, where digital is just one piece of the puzzle, is critically important, and so are working every day to try to achieve that. Thank you.